fellas. It's a double feature this time. The subject is carburetors for both the Cricket and the Colt. Either of these cars may show up in your service department, so it will be to your advantage to know both sides of the story. And to tell this two-in-one story, we've got two good men. Mike, who knows Cricket carburetors from depression chamber to starter valve assembly. And Fred, our man with the know-how on Colt carburetors. Let's begin with Cricket. Ready, Mike?
Ready, Tech. Cricket carburetors look different from more familiar models, so description comes first. The basic Stromberg 150 CDSE carburetor is a single-barrel side draft type. It has a vacuum-controlled main metering system and a mechanically operated starter valve to enrich the starting mixture. Some part names also need explaining. For example, CD is the model designation for a constant depression type carburetor. This simply means that there is always some vacuum in the depression chamber when the engine is running. The S stands for a separate starter valve assembly, and the E for emission control. Now, beginning on the outside of the carburetor, the main components are the depression chamber, starter valve assembly, main body and throttle, float chamber, throttle bypass valve, and the temperature-controlled air bleed valve. On the inside of the carburetor, we have the air valve, including its operating diaphragm and the metering needle, the main jet assembly, and the float and needle valve assembly. Now let's describe the main components. The depression or vacuum chamber is a dome-shaped airtight housing, which also provides an alignment guide for the air valve spindle. This chamber closes off the upper side of the air valve operating diaphragm and the inside of the hollow air valve. In operation, reduced pressure inside the chamber in the air valve allows atmospheric pressure to push upward on the underside of the diaphragm, raising the air valve. A compression-type spring inside the air valve helps to balance the upward movement. The hollow air valve spindle keeps the valve in alignment as it moves up or down. This spindle also forms a cylinder for the hydraulic damping piston and carries the oil used for air valve damping action. Damping piston action prevents the sudden upward movement of the air valve when the throttle valve is opened quickly at low speeds for acceleration. However, as the throttle valve closes, the spring-loaded air valve can move downward with no resistance when depression chamber vacuum drops because the air space above the damping piston is vented through a drilled passage. Next, we find that the main body of this carburetor is a plain tube with no protruding nozzles or venturis. It has a throttle valve at the engine manifold end and an air valve opening in the midsection. A raised floor section narrows the main bore in the main jet area. This raised section and the air valve form a venturi opening as the valve moves up and down. The air valve is essentially a hollow piston, which is slightly larger in diameter than the main bore. Airflow under the valve transfer holes partially evacuates the area above. This reduces chamber pressure and causes upward valve movement. The air valve also moves a tapered fuel metering needle in or out of the main jet to control the mixture in direct proportion to the throttle-controlled airflow through the bore. In short, the throttle controls the air valve, and the air valve metering needle controls the fuel flow. The main jet assembly is basically a calibrated tube extending up from the float chamber into the raised section of the main bore. Since the tapered air valve needle automatically varies the jet opening to provide the correct fuel flow for all engine running conditions, no other fuel metering circuits are needed. At all running speeds, the air valve and throttle regulate airspeed through the bore to maintain a constant flow of air over the main jet opening. This flow atomizes the liquid fuel to help it mix with the incoming air. The float chamber is a conventional fuel reservoir bowl which feeds the main jet and the starter valve. It has the usual needle valve and float assembly to maintain the required fuel level in the chamber. Now, as I mentioned earlier, the CDSE carburetor has a manually operated starter valve assembly to enrich the starting mixture. This unit produces the same results as a conventional choke valve, but in a different manner. Pulling the choke control out opens one in a series of rotary valve ports to admit extra fuel from the float chamber into the main bore. Control operation also causes the fast idle cam to open the throttle valve to its starting position. Operation of the automatic choke, or starting valve, used on some models is covered in detail in a Cricket service bulletin, so we can go on to other things.
You're doing a good job, Mike. But I think we need a little more on how the running mixture varies with changing engine operating conditions.
Okay, Tech, we'll begin with startup conditions. Now, with the engine stopped, the air valve rests on the raised section in the main bore. The valve restricts intake airflow when the engine is cranked, so we have a low-pressure area on the intake manifold side of the valve. The reduced pressure causes the air valve to lift slightly with each piston intake stroke. This valve action starts fuel flow at the main jet and admits air so the engine can start. For cold starting, additional fuel is usually needed. As you already know, the starting mixture is temporarily enriched and the throttle valve is opened slightly to provide the required mixture for starting and running. At idling speed, the air valve lifts a small distance above the raised section in the bore. The amount of air passing under the air valve and the quantity of fuel in the mixture are determined by the throttle opening, which is set by the slow-running speed adjusting screw. As the throttle is opened from idle, airflow under the air valve increases, so the pressure drops in the depression chamber. As a result, the air valve lifts higher in the main bore. And when the increased airflow stabilizes, the pressure in the depression chamber balances with atmospheric pressure below the diaphragm, so the air valve stops rising. In fact, with a constant throttle opening, the air valve literally floats in the main bore. As a result, airflow and fuel flow are controlled to provide the exact mixture ratio and amount of mixture required by the engine at that speed and load. In the reverse order, as the throttle closes, less air flows under the air valve, so the valve moves downward. Here, the spring in the air valve performs its other function by helping the valve close. Generally speaking, we can sum it up like this. As the throttle valve opens, the air valve lifts in proportion to the degree of throttle opening. And as the throttle valve closes, the air valve drops, also in proportion. However, heavy loads can hold engine speed down even with the throttle fully opened. Here, the air valve and metering needle raise only to a part throttle position, but the pressure drop on the engine side of the air valve increases fuel flow to maintain power. In comparison, when the throttle is opened suddenly at low speeds for acceleration, airflow immediately increases under the air valve. This reduces the pressure in the depression chamber, and the diaphragm tries to raise the air valve. If the air valve lifts too quickly, too much air is admitted into the intake manifold, and the running mixture goes lean, causing a flat spot or hesitation. To prevent this momentary lean condition, the damper piston slows air valve upward movement, and this restricts airflow through the main bore. The resulting pressure drop on the engine side of the air valve increases fuel flow from the main jet to overcome the lean condition. The additional fuel flow tapers off as the air valve lifts against damper piston resistance. When the air valve reaches its float position, the fuel flow is normal for the degree of throttle valve opening. And that just about covers the basic CDSE carburetor, except for the slow-running or idle air adjustment screw and the temperature-controlled air bleed valve. These carburetors also have a throttle bypass valve, which provides running mixture to keep emissions low when the car is coasting with the throttle valve closed. This bypass mixture maintains good combustion to keep unburned hydrocarbon emissions low. And there's more about these features in the reference book.
Well done, Mike, and right on time. We've used up our cricket time for this session, so we'll move on to the Colt as soon as someone turns the record over. All right, Fred, what do you have for us on the Colt carburetor?
Well, my job should be fairly easy because this carburetor and its parts look more familiar. But we'd best begin, as Mike did, with an overall description. First of all, the Colt carburetor is known as a compound two-barrel type. All this means is that we have, in effect, a four-barrel carburetor split in half to provide single primary and secondary sections. Now, let's identify the main components. Viewed from the left or outboard side, we have the idle compensator, the primary throttle positioner assembly, the fuel shutoff solenoid valve, the bypass screw, the pilot or idle mixture screw, the primary pilot mixture jet, and the accelerator pump assembly. On the firewall end, we see the automatic choke assembly with an engine coolant hose to the throttle body, the depression chamber, which operates the secondary throttle valve, and the levers, linkage, and adjustment screws, which we'll describe more completely farther on. The side facing the engine has the secondary pilot mixture jet, which is similar to the primary mixture jet on the outboard side, and the primary mixture enrichment valve assembly. On the fuel inlet end, we have the transparent float bowl window, which makes it easy to check the fuel level. The level's okay if it's within the top and bottom limits of the indicator dot with the engine running at idle speed. As we look down into the primary section, we see the choke valve, the accelerator pump outlet jet, the primary venturi, and main nozzle. This section also has a primary bypass port and a pilot or idle port below in the throttle valve area. The secondary section also has a venturi and main discharge nozzle, plus an idle port. The secondary throttle valve remains closed until opened by the vacuum-operated depression chamber assembly. Now, as for the individual component functions, the idle compensator is a bimetal-controlled, temperature-sensitive valve which admits air below the throttle valve to offset flooding and hard starting when carburetor temperatures are high. As the name suggests, this valve is most effective at idle and off-idle speeds. The primary throttle positioner is basically a vacuum actuator linked to a pickup lever which contacts the primary throttle lever. Positioner vacuum is controlled by a solenoid valve operated by a speed-sensitive governor switch. In operation, throttle positioner action prevents the primary throttle valve from closing until engine RPM drops below 1600. This throttle closing delay helps to control exhaust emissions by maintaining a good combustible mixture when the car is decelerating.
Just remember that when the throttle positioner is on, you get a freewheeling effect on a coast down. When the positioner releases, the resulting effect feels like a transmission downshift. What's next, Fred?
The fuel shutoff solenoid plunger cuts off flow in the primary idle system when the ignition switch is turned off. This shutoff action permits the use of a relatively high idle speed to reduce emissions without the disadvantage of after-running. The bypass screw, located directly under the fuel shutoff solenoid, is adjusted and sealed at the factory. The primary pilot or idle mixture adjusting screw has the usual plastic cap, which limits its maximum rotation in either direction. The primary pilot mixture jet meters fuel from the main jet well as it flows to the idle port in the primary main venturi.
Don't be fooled by the blind outer hole in these jets. It doesn't go anywhere. Right, Fred?
Right, Tech. Next, we have the automatic choke assembly, which includes the fast idle mechanism. Engine coolant flows through the choke outer housing to keep choke operation closely matched to engine temperature. The choke valve is attached to a solid shaft extending from the choke mechanism housing directly into the primary venturi. This valve is closed by a conventional bimetal coil spring, which is opposed by a diaphragm-type vacuum kick unit. The fast idle cam is located on the choke shaft behind the shaft operating lever. The cam and lever are connected by a light spiral spring, which loads the cam in the on direction as the choke closes. Now, let's see how the choke operates. As the choke spring cools, it closes the choke valve. However, the fast idle cam lever locks the cam in the off position until the gas pedal is depressed. When the cam is released, the light coil spring moves the cam into an appropriate fast idle position. The fast idle cam follows the choke spring and moves in the high step direction as choke spring tension increases. This produces an idle speed in proportion to the choking mixture. And as a final point here, an unloader tang on the cam lever partially opens the choke valve when the throttle is held wide open. This action aids starting by helping to clear the manifold of over-choking or flooding conditions. Now, moving on, the depression chamber is a simple vacuum actuator which opens the secondary throttle valve when the driver demands more power and performance. The chamber connects to ports which open into both the primary and secondary venturis. Here's how it works. When the primary throttle opens beyond the medium load range, increased airflow past the primary port reduces pressure in the chamber enough to open the secondary throttle valve part way. Additional airflow past the secondary port then helps to open the valve fully. Next, on levers, linkage, and adjustment screws, the names explain the functions. Here we have the primary throttle stop or idle speed screw, the primary throttle positioner adjusting screw, the fast idle cam adjusting screw, and the secondary throttle stop screw.
On earlier models, you adjust the throttle positioner at the positioner stem. Also, the fast idle cam is set by bending the cam lever link rod. The remaining adjustments are essentially the same on all Colt models.
Thank you, Tech. Now, moving to the engine side, we have the secondary pilot mixture jet, which has the same basic function as the primary pilot jet.
If you switch these two jets around, there'll be trouble. And if they're loose, you can get rough idle, surging, and power loss. So be careful.
Good points, Tech. The remaining component on this side is the enrichment valve. It's vacuum diaphragm operated and admits extra fuel into the primary main discharge circuit when a power step-up is needed. We've already talked about the fuel level window and checking the level. However, if adjustment is needed, be sure to bend the float support plate at a point away from the needle valve. Now, to help in troubleshooting, let's describe internal circuits. The slow speed or idle circuit feeds fuel from the primary main jet through the pilot jet. The circuit discharges at the bypass port or at the pilot outlet, depending on the position of the throttle valve. At the same time, bleed air is admitted at the primary venturi and through the pilot jet to produce the correct bypass and idle mixture. This mixture flows normally when the fuel shutoff solenoid plunger is retracted, but stops when the plunger blocks the mixture passage. The primary and secondary main circuits both feed from the float bowl through separate jets. Bleed air is admitted to both sections through air jets in the separate nozzle and venturi assemblies. The accelerator pump circuit feeds into the primary venturi. Fuel from the float bowl flows past an inlet check valve into the pump. From the pump, fuel flows past an outlet check valve to the jet nozzle. In addition, the enrichment circuit also feeds into the primary venturi. Fuel passes from the float bowl through a jet into the enrichment valve. The manifold vacuum which operates the valve is routed from a port below the secondary throttle valve. Next, the automatic choke has two circuits. One routes vacuum from below the secondary throttle valve to the vacuum kick unit. The other leads coolant from the engine block into the choke outer housing and then back through the throttle body passage. The throttle positioner assembly also has two circuits. The vacuum control valve solenoid circuit includes the governor switch and a clutch or transmission switch. Operating vacuum is routed through a passage which opens below the primary throttle valve. Well, Tech, except for specific adjustment procedures, that's the story on the Colt carburetor.
And it's a good place to break off because we don't have time left to get into those details here. Anyway, the service manuals and bulletins should always be checked for the latest specifications and service information. The material in your reference books will help you remember things that Mike Cricket and Fred Colt covered so well in this session. Be sure you don't miss the added service hints. So long for now.